Students, this is Ravi Shankar again seeing you through the next video, and in our last video we have studied about the problems regarding the electrical force, but the exercise problems has to be dealt again. That we will do it after seeing some more theory. So today let us start with the next topic, and the next topic we are calling it out as electric field. What do you mean by this electrical field? This electric field is represented by the letter E vector. This electrical field is an vector quantity, and this electrical field's SI unit, it is measured in SI unit as Newton per coulomb or volt per meter. Let us see how you got this later on. Just a small concept regarding the electrical field. Already we have studied about the Coulomb's law. What you have studied about this Coulomb's law? You are having a charge Q1 in your medium. If you are bringing another charge Q2 from a large distance towards this charge Q1 at a distance R, this charge Q2 interacts with this charge Q1, and that interaction we are calling it out as electrostatic force. That electrostatic force we have stated it as F vector equal to constant K, or we can write 1 by 4 pi epsilon 0 into Q1 into Q2 divided by R square into R cap. This electrostatic force is due to interaction of this one charge with that of the other charge. So that interaction, when you are considering that interaction, otherwise generally called to be force, may be either attractive or repulsive. We very clearly know that they are repulsive if their charges are of same nature, and attractive if they are of opposite nature or different nature. Now, a question arises. What is that question arises? See, you are having the charge Q1. Now, bringing the charge Q2 at a distance R, an interaction is available, and interaction is produced or interaction is available. How the charge Q2 knows? How the charge Q2 knows the presence of Q1 or the existence of Q1? See how this charge Q2 knows the existence of Q1 so that it can able to interact. For this question, answer given was the solution, or the answer is given by Michael Faraday, by considering a new concept called to be electrical field. That is what we are going to study about this. A small introduction regarding this. So now how you can say or how you can define electrical field? According to Michael Faraday, each and every charge available in this universe, each and every charge that is available in this universe, every charge in the universe or in the medium, around that or surrounding, there is an influence. Around that charge, there is an field, or there is an influence of the charge. There is an influence of the charge. See, when you are considering a charge Q or Q1 surrounding this charge, you can able to say, according to Michael Faraday, the influence of the charge is available. The area or the space or the area surrounding the charge, surrounding the charge, where the influence of the charge can be felt, where the influence of the charge can be felt, that area or that space is called to be electrical field, or generally Michael Faraday called that space as field. See, if you are taking another charge, if you are considering another charge, let us consider this another charge as Q2. If the charge Q2 or any other charge is brought inside this space, called to be its influence or called to be its field, then these two charges, what happens? These two charges interacts and they give rise to what? They give rise to the electrical force. So, when the another charge is brought nearer to that of the first charge or within its area of influence or within its area of field, then it interacts. So, the definition that was being given now as, so in general, how you can able to define? So how you can able to define? In general, it was given as, that the space or the area, around அல்லது surrounding the charge, in which the influence of the charge can be felt. The influence of the charge can be felt. Influence of the charge can be felt. That we are calling it out as electrical field. So, you go through this again. In general, the space or the area around or surrounding the charge in which the influence of the charge can be felt is called to be electrical field. This is a general definition not given in your book. So, how they have explained in your book? So, let us go for the explanation. So, what is the explanation that we are having by Michael Faraday? So, the explanation given was, you consider a charge Q. So, consider a point charge Q. Consider a charge Q. Now, consider another charge called to be test charge. So, this test charge is represented as Q0, or you can take this test charge Q0 as unit positive charge. You can consider this test charge as unit positive charge. This test charge is a small point charge, or we can consider it as a point charge. So, the dimensions of this charge is very small. When you are comparing these two charges Q and Q0, Q0 is considered to be very small. So, we are representing it as test charge. how I can able to get the electrical field now. So at one point I am having the charge Q. So according to Michael Faraday's concept, this charge Q surrounding this, it may have its influence. Okay, surrounding this, it may have its influence. Within this influence or within that field, you place another charge, that is the test charge Q0. At what distance? You are placing it at a distance R. If that is the case, then first of all we can state the force F or the force F vector given by Coulomb. According to Coulomb, this force F vector is 1 by 4 pi epsilon 0 into Q into Q0 divided by R square multiplied with R cap. If you want, you can write this. Instead of this, I can able to write it out with the help of K. Okay, now this charge Q creates an electrical field in the surrounding space. That electrical field at this point, if you are taking this point as A and if you are considering this point as P, then electrical field at this point P at a distance R from this point charge Q is nothing but this force experienced. Clear? See how Michael Faraday explained was, see the electrical field, okay, in particular the electrical field at the point P where you have placed the test charge, where it is at a distance of what? It is at a distance R from the charge Q. So I am going to calculate the electrical field E at this point P at a distance R from the charge Q is nothing but is the force experienced by the point charge by the unit charge or by the test charge or unit charge, and it is given by electrical field E vector is equal to force F vector developed at a point where you are having the test charge Q0. Clear? So this definition is in particular. How you can able to define it out with the help of this concept. I am again recalling, you see, in order to determine or define electrical field E vector, consider a charge Q at a point A. Let us write at the point A. Okay, when you are considering the charge Q at point A, then around this charge you are having the electrical field or the field or the space in which the influence can be felt, called to be the field. Now in that field you consider another point P. At this point P you place a test charge or a unit positive charge. That test charge or this unit positive charge, when placed at a distance R, the two charges interact with each other. When the two charges interact with each other, then we can say that F vector is equal to 1 divided by 4 pi epsilon 0 into Q0 by R square into R cap. See, what is this? A force is experienced on this test charge Q0 at this point P at a distance R from the parental charge Q, and that force experienced per unit charge is called to be electrical field. that was written here in your book term. According to your book terms, the electrical field at point P at a distance r from the charge q is the force experienced by the test charge or unit charge given by. See, in a simple manner we can able to define from this. So, in a simple way, how I can write simply, okay, I can write consider like this. Simply, I can say that electrical field is nothing but force per unit charge, force per unit positive charge or force per unit test charge, that is called to be the electrical field. This concept is being explained here like this. See, the electrical field at P at a distance r from Q is, see, இது எதுவுமே தேவையில்லை, டைரக்டா எழுதிடலாம். The electrical field, you take this alone, the electrical field, if you want you can write at a point P is the force experienced by the test charge or by unit positive charge. So the same thing I have written here in a simple manner. Electrical field is nothing but, that too you can leave it out. We can say like this: electrical field is force per unit test charge. Electrical field is force per unit test charge. So you can, how you can write? You can write it out as E vector is equal to F, or you can write like this: modulus of E vector is equal to modulus of F vector divided by the test charge Q0. See, here I have given you the magnitude. From here I can state the unit. Force is measured in terms of Newton. Charge measured in terms of an unit coulomb. So the SI unit I can write it out as Newton per coulomb. SI unit I can write it out as Newton per coulomb. I think you are very clear, or you are having a very clear idea regarding the electrical field. See, you may be asked a question, but it is not given in your book, but a simple question may be asked. See, like this, the question may be: obtain an expression or equation for electrical field at a point. Electrical field at a point due to a point charge. You may expect a question like this in 3 mark. Direct answer was not given in your book, but I am going to write the same thing but in a simple way. So you consider a charge Q at point A in your medium. At a distance r, you place another point. Let us take that point as P, and at that point I am placing the test charge Q0. So simple, you write some 1 or 2 lines of description. You have to write like this: consider a source charge. Okay, let us consider as parental charge or source charge as Q in your medium. Okay, in your. Next, place a test charge. Place a test charge at a distance r. From A at P, where the electrical field is to be determined. Or let us write it out like this: found. So first of all, you calculate what this is, a small description. Now you calculate, let us go for the calculation. So first you calculate the force between, electrostatic force between the 2 charges. What is the electrostatic force between the 2 charges? We know that F vector is equal to 1 by 4 pi epsilon 0 into Q into Q0 divided by R square. But what we need of, we are in need of mod E vector or electrical field vector. As we know from definition, that electrical field is force per unit charge. Electrical field is force per unit charge, or you can write unit test charge. What is this force per unit charge or force per unit test charge? See, I can write that is E vector or modulus of E vector is equal to modulus of F vector divided by Q naught. So you substitute, I can write modulus of 1 by 4 pi epsilon 0 into, first of all I am writing this force F, Q0 by R square, then this value divided by Q0. So this Q0 will get cancelled. What is your answer then? 1 by 4 pi epsilon 0 Q by R square. This gives you magnitude of electrical field. If you want to write this in vector notation, so I can write it out in vector form. So how I can write this in vector form? You see, E vector is equal to 1 by 4 pi epsilon 0 Q divided by R square into R cap. So I have written here the electrical field in vector form. So I have to state it both in magnitude and direction. What is the direction? That we shall see later on or in the next video. See, now you compare this answer with the answer that you have determined here. See, E vector is equal to F vector divided by Q0. What is F vector? Here you are having. So, when you are writing the answer here, what is the answer now? For F vector, it is 1 by 4 pi epsilon 0 Q0 divided by R square, R cap divided by Q0 cancelled. So you get 1 by 4 pi epsilon 0 Q by R square into R cap. Purinjida? See, the same concept here I have determined it by asking a question. So you studied this as a concept. This is the concept. After studying this as the concept, you just go for this question and study the expression. This will be your clear-cut idea for getting an expression for what? Expression for electrical field at a point due to a point charge. Clear? Okay. We have to see about the important aspects of this